I welcome you all to the afternoon session of the third day of the 6th-day Atal sponsored FDP. Today we have with us for this afternoon session Dr.V Mahendra. Dr.V Mahendra is a distinguished SOC design engineer, technology trainer and innovation consultant holding a PhD in VLSI, heterogeneous computing system design from NIT Bhopal. With 10 years in academia and 5 years in industry, he is driving force in innovation and entrepreneurship. He has secured substantial funding for research projects, including a 43.8 lakh grant for an on-chip heterogeneous multi-core platform and a 4.5 lakh monograph on resource optimization. Notably, Dr. Mahendra has played a pivotal role in establishing innovation centers like ASIC 470 lakhs and an IPFC 116 lakhs, along with a livelihood business incubator of 50 lakhs, fostering an ecosystem of entrepreneurial growth. A certified entrepreneurship trainer and recognized innovation ambassador by the Ministry of Education, he has published 25 research articles and mentored 5 student startups, showcasing his commitment to advancing technology and nurturing talent. We are happy to have you here, sir, for the afternoon session. I request Dr.V Mahendra, Head of the Department, to welcome sir to the block podium. Please, sir. Thank you, sir. Thank you, ma'am. I request sir to please take over the
Good afternoon. This is my name is Dr. Mahendra. I would like to thank Chief sir and Mahendra for going to now. So here, let us share with our experiences. Actually, this is the FDP. You know, most of the audience are faculty. And I know actually I am in academia around for 10 years. After that I moved to the industry. So I know the culture of academia and university. Yeah, that's why here let us have this kind of discussion. Here the topic is application of AI in the VLSI industry. Right? So here let us understand what are the VLSI technologies and techniques what we apply in the industry and how to implement AI. That is what main agenda. So today's our topic is machine learning for physical design optimization. I hope everyone knows what is physical design. Am I right? This topic is covered in the yesterday's and today's session. Is it covered? Physical design and VLSI design flow. Yes. Overall VLSI design flow is covered. Am I right? Please take this as the kind of discussion session, okay? Please not a lecturing session, but because you are the faculties and you have to understand the concepts and you have to take it to the students. Then only industry can survive. Otherwise, industry cannot survive without your support. That's why actually, as they are asking, I accepted readily. So let us understand first what is physical design, and then let us see how AI can be implemented to the physical design process, right? Yeah. This is the content what we are going to discuss today. First, we will understand what is machine learning. Already we have understood the first session itself, right? Now I hope everyone knows what is the machine learning. So here in this session we are going to understand how to apply the machine learning concepts to the VLSI. Next, VLSI design flow. Let us see what is the VLSI design flow. In that there is physical design. That also we are going to understand in detail. Here I will not discuss much about the VLSI design flow as it is already covered. I will be focusing more on physical design, where what are the various steps in physical design and how to optimize this process. right? After that, we will discuss the ML techniques which can be implemented for the physical design, and finally, we can see what are the challenges of implementing ML in the various industry. Now, these are the various topics what we are going to understand in this session. Yeah, now I hope now this is what machine learning. Am I right? Already I have understood what is machine learning. Now can you see? If this makes sense? Just see the diagram. There, what is the difference between these two? Traditional programming as well as machine learning. Now I hope in the first session you understood what is machine learning. Now here clearly I can say a traditional programming what that do, that takes the algorithm and that gives the output. But whereas in machine learning takes the algorithm and produces, takes the output and produces the algorithm. So here the outcome of the machine learning is kind of algorithm that can be applied to optimize the process, right? That is how the machine learning can be applied in any industry, not only in VLSI, but any industry. Machine learning can be applied in this way. We provide some minimum inputs to the machine learning algorithm that provide us the algorithm which can be applied for our flow. That is what the process, what machine learning follows. Next, let us see what are the challenges. It is not kind of challenges, opportunities I can say. Right? These are the various challenges we are facing, and that can be converted into the opportunities in terms of machine learning. Now you can see here the design complexity. As you are seeing 10 years back, the complexity was very less. Am I right? The process was running at less than 1 gigahertz or up to 2 gigahertz. No process are running more than 2 gigahertz speed, right? So along with that, there is memory requirements also high, and the competition speed, especially if you want to apply the processor, or if you want to use the processor for machine learning or AI applications, we need high speed processor. Am I right? That means that can work at a high speed, and that is possible only when we can keep the memory on the same chip. Am I right? I hope you know what is how memory is interconnected in VLSI chips, right? So if you want to enhance the speed of the chip, automatically that memory should be sitting on the same chip. That is what you can say cache memory, right? In the microprocessor subject you can see these concepts, right? Where memory, if memory is nearby, then computation speed will be enhanced. If that is very far, then most of the time is wasted for communication, right? So that is how this complexity comes to a role, because nowadays AI chips are wanted more complexity, right? Next is predictability. See, if I change something in the chip and how that produces the output, right? That kind of prediction is required. Nowadays, that prediction is very important, right? Because we need to reach the market at a high speed in the sense quick, right? If I got the thought today, within a 6 months or maximum 1 year, I have to put that into the market. Otherwise, other person, other competitor can come and they will release their product and our investment will become loss. Right? That is the major challenge in the industry. That is predictability of the new implementations. If I do something new, how that will affect the market or feature or whatever intention is the design for. That protection is very important. That is not possible very quickly by the humans. So we need to depend on some technology. That is what now emerging machine learning and AI. Next, number of iterations for quality design. At in a single shot, we cannot achieve management quality. Am I right? We need some iterations. Now I hope you know already. Whenever you are teaching the subject first time, you cannot put complete efforts, right? But fourth time, you will be expert in the subject, right? So you will be dealing very effectively as compared to the first time. Same here also. In first iteration itself, you cannot get optimized results, right? That architecture, whatever we design, that may not produce the 100% requirements. But about the iterations, we can achieve whatever we require. In the process of implementation, we can get some more thoughts. We can implement that in the next iteration. That is how this iteration is very important. But if you keep on purely depends on human interactions and iterations, then again that takes a lot of time and we cannot provide the product into the market in a short time. Right? That is again challenge. Now next one is turnaround time. That is what I am talking. So I got a thought today. Within a 6 months, I need to release that into the market. Otherwise, the company is under big loss. That is what happening with Intel, right? They have got, but thing is, they are unable to predict the future market, right? Now that is again internally they are optimizing some of the activities so that they can come up back, right? So here, this turnaround time should be good enough. For that also again, we need to depend on machine learning. Finally, design quality. This is most important. So our design is not good quality, then our complete investment is waste. Right? Now, that is what you can see the very first Nokia was the mobile phone, but nowadays that is not there. Well, because they have got the good quality at the initial stage, but later on the quality was not as required by the customer. Am I right? By the time when the other companies has come and they have released their product, that is what turnaround time, and they don't have the sufficient time to do the iterations. These all are the challenges for the companies may fail. Now they have got the ML, artificial intelligence, there is a chance of taking it up. Okay. So now these are the challenges in VLS industry. That's why we need to implement the machine learning algorithms in VLS industry. Not need to, already we are implementing. Now we are calling them as virtual agents. If, since we are dealing with the PD agent, physical design agent is the name what they are giving for optimization process, where no engineer is required. That is already there. They are implementing things. This is price. In the 2 to 3 years, that will come up. So again, now every engineer is dealing with the 2 blocks. In the future, one engineer can deal with 5 to 6 blocks in their block. This PD agent. That means again 3 engineers jobs are out. The thing is, there are few more jobs are created for developing these algorithms. See, number of jobs are there, but the human interference is they are reducing their machine learning. But here, the machine learning will help us in these ways. Okay. Now let us understand the actual topic, that is what physical design. How we can implement these machine learning algorithms in physical design. So if you want to understand that, we should know what is physical design, right? Okay. Now let us understand what is physical design and where that physical design is there in the VLSI design flow. Now have you seen this VLSI design flow? I hope everyone is following the same kind of flow. So here there are various steps. Do you want me to explain all these steps? I hope everyone understood already. Yes? That is not required. I will simply focus on physical design. But before that, you can see the flow. What is happening? Now in the system specification, what happens in the system specifications? Anyone please, okay, let us take this as the discussion. Right, don't take this as a lecturing session. Right? What happens in the system specification? User specification. That means some engineer can collect what are the requirements of the customer. Am I right? Customer's requirements can be captured over there. Next, architecture design. There is again architecture engineer. They design the architecture for the user specification. Am I right? After that, there would be RTL engineers. RTL are design engineers, they can call. Right? They can write code, regular system regular behavioral code for the specifications. After that, circuit design. What is the meaning of circuit design? How the code, RTL code is converted into the circuit synthesis. Yes, right. That synthesis process they follow. Again, the synthesis is again big, right? That is not required here to discuss. Just here understand the synthesis process converts RTL or Vella HTL into circuit. Right? After that we have the circuit. Now that circuit will be taken up as input to the physical design. Right? Why? Because in this circuit design, the design is in computer. Right? After that also it will be in computer only. But thing is that take the real shape of manufacturing. Right? Real shape for manufacturing. Till circuit, the process is happening over the tool. Then in the physical design, what they do, they can keep all the components in the circuit together in the small area. In the small area, that area will be in terms of millimeters, millimeter square, 2 millimeter square, or 3 millimeter square, not more than that. Right? But for a chip will be in the centimeters, whatever is coming out. But inside that chip, the core area is in terms of millimeter. Okay. So we have to place the complete circuit in the small area, millimeter square area. That is the process what we do as physical design engineer. Okay. That is what physical design engineering do. After that, after placing everything in the small area, then we need to verify the functionality. Again, the various factors are there. Physical verification we can call that as. That means the shorts, opens, interconnectivity. These all things will be verifying at one stage. That is what physical verification and sign off. After that, the design ETS2 in the format that can be developed and then given to the fabrication. And the fabrication people will fabricate the chip and give us back again. After coming back to the engineer, again they do these tests, static fault test, the fault tolerance. The topic was covered already, right? Many tests will be happening on the fabricated chip. Finally, that will be released into the market. If they find that is good, otherwise they go for patent. Okay, starting from the RTL. They don't go for the specifications because already specifications are fixed. Only thing is we need to verify whether the final chip is meeting the specifications or not. Based on the fault, right? They can go trace back and then they finally produce the chip which can satisfy the requirements. So now let us understand in detail about the physical design. So physical design is again the big flow, right? Like VLSI design flow, there are many stages in physical design. Now I have, you can see those stages also on the screen. Now here we are going to discuss in detail about these various stages. Well, because in our topic we are understanding how we can apply the machine learning techniques to the physical design. If you want to understand that, you should know what is the physical design, what are the stages in the physical design, and how this ML algorithms can affect the physical design stages. Okay. So now let us understand the physical design steps in detail, and then I can tell you how to apply ML algorithms to the physical design. Now here, do you have any queries at this point? I hope these all are known things, right? Now let us understand. First let us see what are the steps. Now partitioning. Did you hear this word? This is not actually not in the academics. VLSI design flow will be in academics. But the rest of the part what I am going to explain, that may not be in the curriculum. Is there curriculum in this index? Is there this physical design process in the curriculum? But you can see that in the tech, there will be 2 or 3 subjects dedicated for this physical design process only. Okay? Now these are the various stages. First partitioning, then chip planning, placement, next block synthesis. This is the most important stage, block synthesis. That is the speed. Next is signal routing. Finally, timing process. Well, because the performance is one of the criteria. So the performance in complete picture is timing. Okay. Yeah. Now look at the inputs what physical design flow takes. Here also we can apply the machine learning concepts. The very first input should be .v file. Here .v file is not RTL file. Netlist. Gate level netlist. We can call it as gate level netlist. Right? That comes from the synthesis. Outcome of the synthesis is gate level netlist. That is circuit. The circuit we will take and we will process that. Then constraint file. Do you know what will be there in the constraint file? Anyone? See, many times I told, take this as there is kind of discussion. See here, what things you are expecting, right? That I am going to give you. Timing information. What kind of information the timing? Please, let us have the discussion. Don't think it is a kind of lecturing. What kind of timing information? Clock information. And also skew. Generated clocks, right? There will be master clock, PLL. How many of you know about the PLL? Did you hear the PLL? Yes? Phasal outlook, what that do? That generated clock at the fixed frequency. But I want another clock with another frequency. What I have to do? I have to take the PLL output. That is called, we can call that as master clock. Right? Master clock. We can generate the master another clock from the master clock. What would be the concept we can use to generate the clock from the master clock? Counters. Divided by logic. Right? In the digital circuits, we will be explaining the concepts of counters, resistors. Right? Those counters are used. If I want to make a half, divided by 2, by quarter, divided by 4, that can be done by introduction of flip-flops. I hope you already knows. That information also will be there. Then logic library. What is logical library contains? See here. Did you hear this logical library over in the previous sessions? Yeah, nanometer. What that logic library contains? Here, other file are there. Attention, sir. Other file is only students, so they are tech students. B.Tech students. Now, sir, we are getting the information. Yeah. See, when we are in B.Tech, we don't know. Okay, most of these concepts. When we start with the M.Tech channel, we don't know. Now they are experiencing them. Right? That's why just asking you. Take this as the kind of discussion session. What you don't know, you ask me, I can tell you. That is what the session is arranged. Not just come here and deliver whatever I want and go off. Right? This is the word we use frequently. Logic library, physical library, right? Technology library. Now these are the various libraries need to be set in order to work in the real-time environment. Right? Just I am asking you, what is the logic library? AOI and OR inverter. See here, there are 3 kinds of libraries. Very good, what he said, that is exactly right. That will have the information. Now here you can see 3 libraries: logic library, physical library, technology library. These are the 3 libraries, very important. Now I will tell you what is the significance of each library. Right? Now logic library will have the behavior of the cells, whatever said, AOI and OR. These are I can say cells, right? There will be cells. Those cells are interconnected as the circuit. That circuit we are going to place in the 4th plan area, right? So here this logic library will have the behavior of the circuit. In the short note I am telling, behavior of the cells, logic cells will be there in the logic library, right? Next, physical library. Now you know the shape of the AND gate. Right? OR gate shape is different. Note shape is different. That shape, outer layer, right? And have you studied the layouts? Layout, stick diagrams, layouts, right? Stick diagram is kind of layout, right? That if you give the dimensions to the stick diagram, that will be the layout, right? That information will be there in physical library. Physical library will have the layout, that is graphical information will be there in physical library. Next, coming to the technology library. See, as one of our friends said, the nanometer, right? See what technology we are going to use for fabrication. 9 nanometer, 7 nanometer. Now we are working on 3 nanometer technology. right? Now current project is happening on 3 nanometers and 2 nanometers, right? I am working in the 3 nanometer technology. So that technology which we can use for fabrication, right? That information will be there in technology library. These are the 3 libraries, very important libraries, right? So apart from those libraries, we have few more libraries. ASIC coefficient library. What is that? See here, capacitor, resistor capacitor. See, whenever we are, see, circuit means it is not only logic cells. You will have the wires also, interconnecting wires, right? Whenever we interconnect the wires, that means we interconnect the cells through the wires, that wires also will produce some delay, am I right? So that delay information of the wires will be there in our TLU plus library. And the power information, what is that UPF? The power, whatever power structure, power architecture. See, there is circuit. That circuit is running on the power, am I right? So what kind of power can be used and how can power can be distributed over the complete chip is information. That information is available in .UPF file. So that is power file. Finally, MMMC. What is that MMMC? Did you hear the tool? Excellent. Multi-mode, multi-corner. What is meaning of multi-mode, multi-corner? See here, whenever you are going to manufacture the chip, that chip should not be manufactured only for 25 degrees centigrade. Right? That can be manufactured for various temperatures. Right? And also at various RC delay coefficient. See, already we know that temperature changes, automatically resistance changes. If resistance changes, automatically delay changes. So because delay is directly proportional to resistance. Am I right? That is how this multi-mode multi-corner, we have around 11 corners. We can talk about the corners. Multi-mode, multi-corner. Here multi-mode is functional mode and testing mode. As I said, after manufacturing, we need to test the design. For testing the design, there are some modes. We have those modes and test modes. Right? Functional mode means functionality mode. That is what 2 modes. Functional mode and test mode. Corners are, as your friend said, 25 degrees, 100 degrees, 0 degrees, and also voltages. Not only for 5 voltage. At times, nowadays 5 voltage not at all used. 1 voltage, less than 1 voltage. Right? For 1 voltage, 0.6 voltages. Why? Because we cannot assure always 1 voltage can be supplied to the chip. Am I right? At times that will be high, that may be low. Right? So we need to test that also. The complete information will be there in the MMMC. Right? Now these are the inputs. Why? Because we need to consider complete this information while placing the cells in the core area. Otherwise, the chip will not be manufactured effectively. That is, manufactured also cannot be delivered to the customer. If that delivered to the customer, then situation will be like Nokia. Right? Why I am telling? Same. If you don't test the product and deliver to the customer, customers will be very clear bad feedback. So that will impact your product, not only one product. All the products, whatever is manufactured by your company. Okay? That is how these are the inputs required. Okay? Next, as I said, outputs are GDS2. Right? GDS2. That is the format, layout format that will have the layout information of the complete circuit. Right? And also PPA. What is PPA? Power performance and area. Now these are the major factors. Right? What we need to ensure to happen throughout the flow. Right? Power, performance and area. Right? Those reports. How much power is consumed, how much, what is the speed of the chip, and how much area is consumed. Right? That information we need to take at each stage. Okay, now this would be the outcome of this physical design flow. Now let us look at individual stages. Are you worried? No? If you are interacting, then only okay, the session will be lively. Otherwise, it will be kind of boring only. Now, what is the need of partitioning? See, most of the information I am displaying on the board, just you have to understand that and reply whenever I have. That is what I am explaining. I am providing the information and just I am asking you, so that will enter into the mind, so that will help you in the future. Partitioning. See, circuit will be very big circuit, right? It's not like whatever codes you write in the lab, right? Counter will be very small, right? If you attach 100 blocks also, the size will be very small, right? But here the count will be in millions, right? But placing the millions of components at a time is difficult. So what they do, they divide the complete circuit into small portions. We call them as blocks, right? We call them as blocks, right? Now, in which project I am working, that will have 200 blocks. 200 blocks, right? So the partitioning is very important. But to do the partitioning, we should have some criteria. We should have some criteria. Based on some criteria, we can do the partitioning. We cannot do partitioning like first come first serve, right? We have to think about the logic connectivity, right? And then we can partition the complete design into small portions. Okay? So here you can see here on the board, top one is small circuit what I have taken here. Top one is having how many? 8 cells. So total 8 cells are divided into how many parts? 2 blocks. You can say the circuit is divided into 2 blocks. That in 2 ways. See here, first one is having one criteria. What is that criteria? 4 external connections. Connections between the 2 blocks is 4. Right? This one is 2. 4 connections between the 2 blocks. Here, 2 connections between the 2 blocks. You get what I mean to say? So here the criteria of partitioning the design is the number of connections. At times there will be size of these cells also, right? Based on some criteria we can divide. Now here ML algorithms can be applied here to divide the complete circuit into a blocks, right? That we can see how we can happen. Now see here, the task performed by this particular step is dividing the complete logic into portions. We can call them as blocks, right? And then finally our checks are area of the partition, how much is the area. The next one is shape. See here, based on the partition only we can decide the shape, right? That shape. Top level design is that finally how many blocks and what will be the shape of each block and the shape of the final design, right? That will be the outcome. In between there should be some objectives. Those objectives are said. In the previous slides, what was the objective? Number of interconnections between the blocks, right? But there are a few more such criteria. Here I can say one is number of cells, number of interconnections, and also delay between the portions. Delay between. See, whenever we divide the logic, we need to divide the logic in such a way that delay between the blocks should be less, right? That should not be more. That means the last, whatever the end point should be nearer to the starting point as good as possible, right? So that propagation delay will be reduced. Okay. Next, the next step is floor plan, right? Floor plan. What happens in the floor plan? What is the need of the floor plan? Now you can see the departments in this building. In this building, how many departments are there? How many departments? 5 departments. Each department is in one floor only. Different floors? Yes? Different floors? Okay, you are from the Bengaluru college. here in Bengaluru Engineering College. Students can also have that. Yes, all the departments are in single floor? No. That means this complete building is structured in such a way that if somebody new person from Nara Engineering College, Bengaluru, come here, they can go to 5th floor or 4th floor to meet the ECHOD. Am I right? Why? Because ECHOD is sitting in one place and that place is known to everyone. Right? And whenever ECHOD is sitting in the 4th floor, all the departments, classrooms, departmental classrooms as well labs, everything should be nearby. If that is not nearby, what happens? Complete confusion. Am I right? Whenever new person comes, we have already experienced person, no problem. Whenever new person comes, that new person should know that is easier accessibility. What they do, here they can divide the complete building into departments, right? And they say this is the floor belongs to this department, and all the remaining resources of the department should stay in this floor only. Like that they can say. Am I right? If that is the case, then a new person will not get confused, right? Otherwise, what happens? New person have to start from ground floor, first room, till 4th floor to find the EC floor. Am I right? So that takes a lot of time. If the person is sitting somewhere and that is dedicated and known to everyone, then directly they can come, they can save a lot of time. Same here also. The floor plan plays the major role. Floor plan plays the major role. Why? Because the floor plan only avoids all the confusions. For that, only I have given you that example, right? If the particular location is not known anywhere, then situation will be a different case. They have to start from first room to last room to find the person. Okay? Same applies here also, right? Floor plan is very important. That is what I statement I made. What is the quality of the chip? This depends on this one. And in the real time, if 1 year is dedicated for the project, out of 1 year, almost 4 to 5 months will be dedicated for floor plan only. Right? See the intensity of that particular step. Right? Floor plan is very crucial. Floor plan is good, remaining is kind of important. Right? So, let us understand what is happening in the floor plan. See here, as I said, the complete circuit is divided into many blocks. In this slide, I am showing them as the modules, module A, module B, module C, module D, like that. So, those modules should be placed in the core area. But what is the core area? How we come to know core area? Again, they give the information of the project, that is at the time of specifications. They mention is 3 by 3 millimeter square area is the chip area. So in that chip area, there might be some area dedicated for power connections. Am I right? Pins, everything. And the remaining area will be available for placing the cells. So in that way, the floor plan will happen. Now let us understand in detail the tasks, what floor plan do. See here, in this slide I have mentioned everything. What are the tasks can be performed in the step and how that is impacting a final outcome. Right? See here, since they are given the area 3 mm by 3 mm, definitely we should place all the cells in that area only. So what is need to define? We need to define die-area core area. What is the die-area core area? To decide this die-area core area, 1 month will take. In real, 1 month will take to decide this. Right? If the ML algorithms are applied here, then that will take less time. Right? Our experience percentage less time. Some calculations are involved in here. Right? All those calculations can be done by experienced person. They can come up with a good floor plan within 2 weeks. New person, that takes 2 months. Right? Now see here, fresher and experienced person difference. Fresher can do the job at 2 months time, but the experienced person can do at 2 weeks time. If ML algorithms are applied, that may happen in a day also. So here 2 months time is brought down to 1 week I can say, so less than a week. But experienced person can save 6 weeks of time. That is how the industry persons pay more for the experienced people because they can save the NRE cost, non-engineering recurring cost for 6 weeks time. If they save 10 lakhs, 2 lakhs extra that experienced person can get, 8 lakhs they will save. That is how. Right? So that experienced person is going to replace with ML in the future. That is how the ML algorithms are happening. So now these are the tasks to be performed. See, pin placement can not happen randomly. Why? Because the power rail is at the left hand side. The power pin should be placed near the power rail. Am I right? So like that there are some guidelines. Right? Those guidelines will be the inputs to the ML algorithms. Now that is what I get. ML criteria. What would be the ML criteria? There are guidelines. The pins should be placed in this way. Right? Macros. What is macro? Did you hear the word macro? Memory, RAM, analog, PLL. As I said, PLL is kind of macro. Right? That cannot be programmed. PLL requires the oscillator. That will come from the analog. So they can make that structure and they can give that PLL as one macro, one circuit. Like AND gate, OR gate, that will be one macro. So that will have many connections. Like that, macros need to be placed nearby. Whenever you are placing the PLL nearby, the clock most of the cases goes to what? Memory. Am I right? As your friend said, memory also macro. See, there is PLL or macro, memory is other macros. So PLL macro should be placed near the memory macro. Why? Because the memory requires the clock. Why? Because memory is nothing but registers, interconnection of the registers. Am I right? Will you agree with me? They can run at particular speed. They can read and write the data at speed, at particular speed. That requires a clock. So that clock should be placed nearby the memories. That means PLL is the macro should be placed near the memory. That is one guideline, right? That guideline, how we come to know? Some experienced person, they told us and we are following that. Am I right? How he got the experience? He placed the macro at the corner. That is PLL macro at the corner. Memory is at this corner. Then he got the more delay. Then he found placing that is near to the macro is good. So he placed. Then he got the optimization. Then that is told to the juniors. The juniors automatically place the macro, that is PLL macro near the memory macro. How we come to know? Because of seniority. That is the guidelines, right? There will be guidelines. We give those guidelines to the machine learning algorithm. And if machine learning algorithms get the guidelines, that can do a job better than the human. Am I right? Will you agree with me? Right? So here criteria is IO pin placement, macro placement, and physical placement guidelines. Right? Physical cell placements. Now here one more thing. Do you know what are the physical cells? Physical cells. I hope macros, everyone understood what are the macros. Memories and PLL. Most of the cases these are the macros. At times, particular logic can be converted to the macro. Particular logic, which is fixed logic, can be converted to the macro. I can say in the microprocessor, arithmetic logic unit. If you hear the arithmetic logic unit, that can be taken as macro, right? That can be taken as one of the fixed macro. Like that, fixed components can be called as macros. So macro, you understood, and what are the macro guidelines also understood. There are some guidelines for you. Similarly, what is the physical cells? If you hear the physical cells, boundary cells, tie cells. What is boundary cell? Anyone from this talk? What is tie cell? What is boundary cell? See, this session is arranged for knowing unknown things. Am I right? Will you agree with me? If you know, then okay. You can answer. Otherwise, I will give you the information. What is boundary cell? What is the idea of the boundary cell? Tell me. See, the topic applying the ML algorithm in the various industries, not everyone already apply, right? But how to apply the information you need. If you want to know that, you need the concept. Then whatever, okay, the application, what I am going to explain, that you will understand. What is physical cell? చెప్తున్నారు యా అండర్స్టూడ్ కానీ ఈ సెషన్ ఎందుకు పెట్టారు 10 minutes వాట్ ఇస్ ద సిగ్నిఫికెన్స్ ఆఫ్ దిస్ సెషన్ సిలబస్ ఉంటుందని చెప్పాను కదా కాదు కదా దే ఆర్ కాలింగ్ ది పర్సన్స్ ఫ్రమ్ ఇండస్ట్రీ బై పేయింగ్ సమ్ అమౌంట్ am I right? Did not come here for free. Yes or no? This is my college, that's why I make one. But usually industry persons will not come to the academics because I have the both backgrounds. I readily accept why because I love the teaching profession. But because of some circumstances, I moved to the industry. But whenever I get the opportunity, I love to come here and I want to share my information. That is why I came here. Right? Now physical science, that is not in the academics, right? But you should ask me, okay, what is physical science? What is significance? Please, do you know, I will tell you one story, how I moved to the industry from the academics. As our friend is already trying. Okay, I am the PhD guy and I have good number of projects. Within 10 years, I have executed more than 6 course projects. Right? But I got the opportunity to the college and I took the same opportunity and moved back to the industry. How? I encouraged my management to provide training to the students in the physical design. We brought them to the campus to train the students in the physical design. I also learned. But while going, I am also in the that's all. Why? Because I sat and I learned and I see. As I have done the PhD, I can understand the things better. Right? And industry requires the people who knows the concept or who understand the concepts better. The kind of same. You also got the opportunity to understand the industry requirements. Understand. And then use the opportunities to move away. See, you don't want to stay lifetime here, am I right? I don't think so. Yes? Use the opportunities. Whenever industry person is coming, you don't know the physical cell. You should ask me, what is the physical cell? What is the significance? Right? You are telling about the physical cells. What is that? Your friend said, boundary cell. What is the need of the boundary cell? Tell me. What is the need of boundary cell? We did not study that in the syllabus. Am I right? In the syllabus, you have studied OR gate, AND gate, NOT gate, buffer, am I right? And also counters, registers, blocks, 4 types of blocks, all those things only studied. We never studied the physical cell. Yes or no? But that is there in the syllabus, but you don't know that the physical cell. So friends said boundary cell, we can call that as, another name is handicap cell. Right? What is the significance of this? What this cell contains? That contains nothing. That can be used as a safeguard. As your friend said, boundary cell that can be placed at the boundary to protect the chip. What is the need of the protecting the chip? See, whenever manufacturing happens, how many of you know about the manufacturing process? Photolithography. We hear the photolithography process. In the photolithography process, what happens? The laser beams are used to HT area. Whenever it goes to the edges, at the edges that has to go again. I have to take the fan. Whenever it is moving from this speed to this end to that end, you will go at high speed. While taking the fan, that may not have that much speed. If speed is less, then intensity, laser intensity will not reduce more. So their withstanding is required. To withstand the boundaries, we can place some dummy cells. Those cells are boundary cells that need to be placed. Otherwise, at the edges, it will be damaged. Then chip will not be used for the purpose. Yes or no? Edge is important. But while manufacturing, we need to take the precautions to protect the edge. That can be done by putting some dummy cells which can sustain the some temperatures. Right? Similarly, another boundary cell is decap cell. Did you hear the decap cell? Decap cell. Decap cell purpose is, see, whenever power supply is given to the circuit, first cell, there are 100 cells, I can say. First 10 cells get the power supply good, but 34th cell or 61 cell will not get the power supply. Why? Because that is traveling from starting to the ending. In middle there is voltage drop. So there is need of boosters, right? So here decap cell is capacitor. And what capacitor do? That can store the charge. Whenever charge is required, that can recharge. So the discharging is required at where? In middle, not at the starting. Right? Middle at the end. The decap cells are required. Those are the physical cells. That also need to be placed. That also need to be placed at boundaries, and also wherever density is more. Density is more. There are 50 cells are sitting nearby, and the remaining portion is 50 cells. This area not required. But here 50 cells are consuming power from the same rate, same connection. So here we need the decap cells. That means ML algorithm can understand where is there more cell density. There that you place more decap cells. Right? Here guidelines would be where density is more than 50 or more than 10, place 2 decap cells. If the density is more than 50, place 4 decap cells. Like that there would be some guidelines based on the density. So those guidelines will be given to the ML. Normally we do, but ML also can do that task, right? So these guidelines we give. That's why they are kept ML criteria. Right? Now we understood 2 decap cells. Like that there are 5 to 6 decap cells based on the requirement they can use. Can you tell me any other decap cell? Sorry, another physical cell? Tie cells. As I said, what is the tie cell? Some unnecessary connections would be there. Right? We need to tie off them. Tie to 0 or 1. Right? For that purpose we can use tie cells. Right? And one more important cell is there. What is that? Yes? No? Okay. Then there is latch-up problem. Did you hear the word latch-up? Right? To protect the latch-up, we can use cell. Right? Like this, there are physical cells. Those physical cells are used for that purpose, and that need to be placed in the floor plan cell. Well, because we can plan, right, core area. Now here there are 2 areas in this, die area and core area. Am I right? Die area means which can be used for the ports. Core area means which can be used for the cells of the design. Right? There should be some gap between them to pass the power lines. Anyway, that much detail is required, but we need to understand basic things. Now here checks are based DRC. What is the DRC? Design rule check. What is the design rule check? Did you study the layouts? In the layout there are lambda rules. Yes, those lambda rules only. DRC. That will check the spacing between the wires. Right? All those things. Whenever we are placing the macros will have the pins. Okay, or macro to macro spacing. These all are the guidelines. Just to verify the base DRCs. Again, there is one more DRC. That is wire DRCs are there. But here, the base DRCs is important. Then congestion. What is the meaning of congestion? If more cells are together, then more consumption of power happens. Right? And also, the connectivity will not happen properly. Because if there are 100 cells, for all 100 cells there is enough signal, right? But whenever we are drawing the signals, that may not have an effect with that. Okay? That may touch each other. Those signals may touch each other. That is what crosstalk, right? Crosstalk, those issues will come. So congestion should not be high. They mentioned the congestion, 40% of congestion, 30% of congestion, or 60% of congestion based on the requirement. All those things we need to verify, right? Getting bored? If you don't want to get bored, just reflect with me. That is only the solution. Right? Today I will try to complete before the time. Yeah? Now floor planning, understood? Any query here? Now placement. What is the meaning of placement? This topic is covered in previous session. No? None. They will cover only the others. Floor. Yeah. What is the meaning of placement? What is the difference between floor plan placement? The floor plan, what we do? Macros, yes. You know, see in the classroom, the infrastructure creating the infrastructure is kind of floor plan. Am I right? See, windows, some places for the ventilation, right? And also flooring, everything they do for what? For what purpose they have done all these things? To provide comfortness. Am I right? Comfortness is good, then attention will happen. But if comfort is not good, then attention will not happen. Am I right? Same here also. Floor plan they do to place the cells comfortably. Comfortably means there are cells which need to be connected with a macro. Those cells should be placed near the macro, that particular macro. There are cells which should be connected with ports, right? Those can be connected, placed near the ports. There are some cells which need to be always together, right? They should not go corners. So all of them should be placed together. All those things. Here I can say simply placement of the standard cells. Standard cells means components in the circuit are standard cells. All those standard cells placement can happen here, right? For this also there will be guidelines, right? Those guidelines will be criteria. Now look at this tasks. What this placement perform? What you do first? Course and global. See here there are two terminologies: course placement and global placement. Right? Next, one more will come detailed placement. Right? See, course placement means rough placement. Detailed placement means fixing. First they will place the cell properly and they will see the timing, congestion, all those things they will check. If that is comfortable, then they can fix them. If that is not comfortable, then they can move a little around. Right? That is how. First is rough placement is course placement or global placement. After that, detailed placement will come. That will fix the placement area for the standard cells. Right? So here, the task performed by this particular step is add placement blockage. What is the need of placement blockages? What is the placement blockage? These blockages will be placed at the floor panels. What is the need of placing blockages?
There is a gap between macro. We don't want to put the standard cell in that block.
Yes, sir. See here, as I said, there is PLL, one macro place, and there are 10 RAMs, or 2 RAMs, and 2 ROMs are placed together. Am I right? In that case, what happens? RAM is big one, right? That have many ports. So all those ports must be connected with PLL, right? For the clock. Yes or no? So there are 1000 wires are connecting the PLL. Then what happens? 1000 tracks should be there. That means area between those two should not be used for standard cells. Am I right? Area between those two macros should be used for routing only. Right? So there we can place the blockage. That means on block will put. Like you are blocking these seats, right? By booking online. That means that seat is reserved for you. Nobody will sit there. Same here also. We can place some obstacles. That indicates that standard cells should not placed there in that area. Why that should not be placed in that area? Because of those are the macros. Connection between them is required. That will happen in the later stage. Now that is reserved for that purpose. So standard cells should not sit in that particular area. That is what that indicates. So blockages also we can place at this stage. Why? Because after this there will be routing. Right? If standard cells are sitting in between the macros, the routing will not happen effectively. Routing, I hope routing knows everyone. Connection between the two standard cells will happen. So finally, here criteria is congestion effort. That means congestion should be minimum congestion. Then timing should be good. Right? Next, area should be effective. Finally, power consumption should be less. When power consumption is less, the standard cells are sitting comfortably. If they are sitting nearby at that area, power consumption is more. Power consumption leads to heat. Am I right? Heat leads to damage or until. Right? That should not happen. We can term that as thermal. Some terminology is there. Right? Thermal runaway. legal, what is meaning of legality? Whether the standard cell is sat in the means defined area or not, right? That means there is some standard cell area. How we come to know that standard cell area? After placing the macros, we can put the blockages. Blockage means this is the area not for standard cell. If the standard cell is sitting in that area, that is illegal. Am I right? So we will stick the legality, whether the standard cells are sitting in unnecessary areas or not. Right? That we can tell as legality issue. Right? So all those things we can verify. Right? Congestion. QR. What is QR? Quality of reports. Right? This always deals with the DRVs. Right? DRVs, maximum capacitance, maximum transition. What is transition? How fast that is changing from 0 to 1, 1 to 0. That should happen fast. That is delay, everything will get delayed. Am I right? So the transition violations, all those things will be taken care in QR. Right? That is not possible to explain each and everything. I hope everyone knows the transition, the capacity, maximum capacitance means load. See, I have the capacity of holding two persons only. Third person is coming nearby, I cannot hold. Am I right? That means maximum capacitance is one capacitor can drive two cells. There are three cells are connected to that cannot drive. That is the violation. So that can flow. This is the cell can drive only two, but there are three assigned to A. Remove one. That is the report that we give. So we can do that. That is what. So the removing can happen by removals only. You also can do. That is what ML will come again here. That will verify the DRVs. Load is high, automatically that will reduce the high load. Right? All those things will happen automatically. Right? Now next. Any query here after this? Any queries? Next, block synthesis. What is meaning of block synthesis? Distribution of block. Distribution of block. See on the slide itself. At the top I have. Because you get these slides also. Right? Use these slides to understand the concepts. But here I can remove. Here I mentioned the physical cells, but I have not written all the physical cells. I have written that will become the nodes. Right? It will not become the PPT. That's why I have not kept all of them. Understand what I am speaking here. We can relate that in the paper. Okay, now you can see the two diagrams before CTS, after CTS. What difference you can see here? What difference you can see? Distribution of clock is not uniform, very first one. Am I right? How do you say that is not uniform? See here, basic concept I will tell you. Most of the chips are running at high speed. Am I right? If any change in the speed, what happens? Instead of picking 0, that will pick 1. Am I right? Yes or no? There are 100 buses are going on the road. If you want to catch the third bus, if it will delay, then you will be entering the fourth bus. Then what happened? Instead of going to one destination, you can go to some other destination. Yes or no? Same will happen here. Data can be picked. Right? That leads to some other issues. Yes or no? So that should not happen. That means we need to synchronize the data. Synchronize data. When synchronization will happen? If clock is reaching all the points at the same speed or at the same time, I cannot say speed, at the same time, then nothing will happen. Yes or no? Clock is delayed, now I can say there are 10 points. Clock is reaching for all the 10 points, then all the 10 catch the data. Yes or no? If for one point clock is delayed, then what happens? Then one point will catch another data. Yes or no? That data may leads to some other issues in the future. Yes, but that is not possible. Reaching all the points in clock at the same time is not possible without our efforts. Right? Our efforts is that one. What is that? Building the clock tree network. Clock tree network will have only buffers and inverters. See the below one. You can see the below one is the same network but added buffers and inverters. Is there any inverters added? Why do we need to add the inverter? If some logic need to pick the data at negative edge, right? I hope everyone knows what is positive edge and negative edge. Yes, positive edge and negative edge. Normally data is read at positive edge. Am I right? Yes or no? But if you want to read the data at negative edge, then you can click that. How flipping will happen? Inverters. So you can see that side network will have the negative edge of the clock. This side network will have positive edge of the clock. That is one difference you can see here. Any other difference? Now all the points, right? All the flip flops, I can say flip flops. All the flip flops will get clock at the same time. But at the top you can see this one will get fast. This one will get at slow. Right? That is not the point here. All the flip flops are capturing the clock at the same time, are getting the clock at the same time. That is very important. Otherwise, what I said, instead of going your destination, you may go to some other destination. Same will happen here. That will again wrong. Because of that, companies will collapse. Not customers will not have anything. Customer is there, they are not liking this, they can purchase another one. But companies will get collapse. Right? Companies collapse, engineers are on the roads. Yes or no? That is the situation. So we have to protect our company. That means we need to do valid work, and that can be done by using some tools. Right? But here the scenario is we are going to use the ML. But that means ML also we are have to write. Computer science guy cannot write the ML algorithm for VLSI. Am I right? Will you agree with me? Computer science guy cannot write code for VLSI. We only have to write that. That means our job is just uplifting someone. But further we need to learn one more language additionally, that is Python. Right? Most of the cases Python only. But Python also can do these tasks. But Python is the one language used by the ML algorithms. See, ML algorithms we cannot edit. We can use the algorithms, ML algorithms, to develop our own algorithm. Very first time for shown. We are writing the code to develop the algorithm for our node. Okay, by using the ML algorithms. There are six ML algorithms. We cannot edit them. That will be edited by computer science guy. But that guy cannot do our stuff. They can optimize ML algorithm. But implementation of that ML algorithm is for our code, they will come. Okay. Now this will happen in the clock tree synthesis. I hope everyone understood what is clock tree synthesis and what is its significance. Mainly synchronizing the data. Right? At flip flops will happen through clock tree synthesis. And you know what is the need of synchronization. Okay. Next. Here main point is skew. What I said now. What is the skew? See here. Here it may reach 2 nanoseconds. Here it may reach 3 nanoseconds. Difference between these two is skew. That means the skew is delay of the clock between two flip-flops. Right? That is what the skew. Skew should be minimum. I cannot say 0. 0 is always great. But if that is 0, what happens? Not congestion. All the cells will start running at the same frequency. Not same frequency, you can say. That may lead to another issue. Right? Power consumption will be very high. So that's why skew should not be 0, but should not be very high. That's why there are some time margins will be there. Time margins. Right? That's why we can set skew, but that skew is somewhat not zero. Understood? If that is zero, then dynamic power consumption will be high. That dynamic power consumption will lead to again another issue. Okay, that's why you can set the skew targets. That is what they task see here. Set skew and latency target. Right? That also we have to set. Otherwise, another will happen. Understood? Now these are the tasks we will perform in clock synthesis. Define generated clocks and virtual clocks. Why? Because master clocks are already there in the form of the macro, right? PLL are the macros. They generate the master clock. From those master clocks, we need to generate some other clock which can be suitable for our logic, right? In the chip, all the circuit components will not work at the same speed. Will you agree with me? Memory works at one speed, or ALU works at some other speed, IO device works at other speed. Okay, that is what situation here. Right. Next, routing rules. What is the meaning of routing rules? Now here one more thing I want to say. Define routing layers. Can you see the code? Define routing. What is the meaning of defining routing layers? What is the need of defining the routing layers? Now I hope you understood. Setting the skew target. Is required or not? What is latency? Nobody asked me what is latency. See, the clock is passing from one to another place. Right? There should be some delay. Right? The delay we cannot avoid. But we have to say that should be minimum. Otherwise what happens? Instead of placing the cell here, that will place somewhere else. If I say skew, not skew, latency should be 2 nanoseconds, 200 picoseconds. Then only the cell will be placed here. If I say that is 250 nanoseconds, that means 50 seconds relaxation I given. So that may be placed there by the tool. Stating that some relaxation is there. Why not there? I can place here also. Right? But if we set 200, then only that will be placed there. Right? That will be again calculated by the ML algorithms. Right? Now they are calculating, or some tools are calculating, but in the future, effect will be there by the ML also. Okay? So that is how. Now coming to the define routing layers. Just understand here I am going to give you some minimum information only. Right? But necessary information. Nowadays information is available in Google. Most of my slides are from Google only. But as per the topic, I get rewritten. And I know the concept, so I am going to explain. But with this knowledge you can get the more information from the Google. But here I can give you the minimum information. So now here our point is define routing layers. What is the need of defining the routing layers? What is this are? Yes. B.Tech students all are final year, third year, final year. Yes. So far, faculty, as I said,
Power line should be for
minimum resistance. Yes. Power line should be minimum resistance. Why? Because power drop should not happen. Right? Power drop should not happen. So that rail should have minimum resistance. That means wires for power supply should have minimum resistance. That is what you want to do. Yes.
high metal layers we use.
What is the higher metal layers? Is giving one more keyword. What is the higher metal layer and lower metal layers? Yes. See what I said. The funda is everyone have to understand the concepts. Metals can use that in different way. Students can use that in different way. Right? And already I gave you my approach also. First time for first batch, I will be the listener. For second batch, I will be the trainer. For third batch, nobody is sure. I have to now. Again, industry person comes for the training. That is what the opportunity for the faculties. For the students, again, no need to go for the training institute. But because industry person is here. Okay? And faculty can use this information to write the funded projects also. Right? If you write the linking the machine learning with the VLSI, definitely funded for the universe. But because already I executed the 300 projects I executed on the technology, and remaining are from other, that is innovative entrepreneurship. Okay. So everyone can utilize this knowledge.
I have a doubt regarding this. What are the licenses you are getting in Canada? This is not now for this technology.
See, you will get the license for 65, 45 nanometer technology.
Yeah.
For the industry, we have to pay close. We need to pay the close. And one more thing I will tell you. Here we are going to declare the concepts, not going to manufacture our chips, right? For understanding the concepts, any technology is okay. Okay? That is what I feel, right? For understanding the concept, any technology is okay. That is why those industry people will not.
The industry perfect with the education institutions like this to share their license.
They cannot share now 3 nanometer technology license they cannot share with you. That is useless for you. Understood? Companies itself paying the close and getting those licenses. Okay? But here you will pay maximum 10 lakhs.
Yeah.
Right? But they spend 10 lakhs just for deal. Understood? Just for deal they can use the 10 lakhs. Here you will pay 10 lakhs for 3 years. Yes? And for understanding purpose, any technology is okay. What we have, we need to understand what is physical side and where to be placed, after placing what is the effect, all those things. But here in 45 nanometer, everything will be nanoseconds. In 3 nanometer technology, everything will be picoseconds. That only the difference. But here we are going to understand the concepts. To understand the concepts, any technology is fine. Okay? Yes. What is your friend given one more key? What is that? Higher metal layer, lower metal layer. What is that meaning? See here I said define routing layers also very important. Am I right? And your friend said again resistance. See here, what is the equation for the resistance? R equal to rho L by A. Will you agree with me? R equal to rho L by A. Now wire will have length and also width. That means length and width, rho L by A. L, take it off. Why? Because wires will be long or short, that depends on us. If that is 100 meter, not 100 meter, I can say 100 nano, then I can cut down that to 25 nano by placing the buffers. So length will be less by placing the buffers in between. Length will be controlled, but width cannot be controlled. Am I right? See here, area is, what is the equation for area? Length into width. Length into width. Rho L by A. A is at the denominator. Am I right? So if width is more, resistance will be less. If the resistance is less, delay will be less. That is what higher metal layer means. The metal layers having more width. The higher metal layers. Lower metal layers will have less width. Right? So here there will be more than 10 metal layers we can use. Higher metal layers we can use for power supply. Next kind of metal layer, that is M8, M9. If I give the name M0 to M12, I can say M0 to M12. 11, 12 is used for power. Right? 8, 9 can be used for clock. Why? Because clock also running at high speed. Right? Clock also running at high speed. That also requires less delay. So I can assign the higher metal layers. That means here I can assign what are the metal layers can be used for building clock tree. Right? And also I need to define what are the inverters and buffers can be used for building the clock tree. That means what are the components required to build the clock tree. All those things we can set, and then we can start building the clock tree. Right? And the skew latency also target we can set, and finally clock process will happen. Okay? Clock tree synthesis means building the clock tree. Okay, next checks. Here criteria is again ML algorithm can take skew, right? Latency, now whatever I kept under the criteria, those all will be the criteria that can be taken. Okay. Next, signal routing. Next topic is signal routing. Now, as I said here, there are two kinds of routing again: global and detailed. Global means of, detailed means complete routing. Okay. Now here, see here, what is the signal routing? Making the physical direction between the standard cells. Right? That is the signal routing. I hope everyone understood what is routing. Here routing will happen. Till now we have not connected the cells. Now this is the cell. And also clocks are connected. After clock connection, what do we need to do? We need to interconnect the standard cells together. For that routing will happen. Right? Now you can see what are the tasks. Signal routing will be happening at lower metal layers. Well, because data cannot be transferred every time. One cell can transfer data whenever it is required. Am I right? But clock will be transferred always. Power also always. That's why those are higher metal layers are used for that. Here, lower metal layers can be used. Right? I hope you understood. Higher metal layers and lower metal layers. What is their significance? Yes. Now here checks are timing, condition, and DRs and LBS. What is DRC? Design rules. Like already we have discussed like layout rules. You can verify the layout rules. Then what is LBS? You hear the word LBS? Yes. Low voltage supply. Layout versus schematic. No more. LBS. You hear the word LBS, guys. This is an opportunity for you. There are placements comes. Okay. Have basic knowledge in this concept. Then they may select. They will not expect wonders from the students. They will expect only whether these people are having basic concepts or not. Right? Only terminology is important. Here I am giving you the terminology. Okay. What I am discussing? LBS. Yes. What is LBS? See, here I kept a lot of information, but I am not going to discuss everything. Why? Because you may get bored, and also time may not be sufficient for that. Already 1.5 hours over. Alright? Yes. If you want some more information or clarification in the information, just ask me. Okay. But whichever is necessary information, I am going to give. LBS. What is LBS? This is also important at this stage. What is LBS? As your friend said, layout versus schematic. What is schematic? What is layout? Now after this, everything will be in the form of the layout. Am I right? So transistors are also in the form of the layout. I hope you know how transistors can be manufactured. Stick diagrams. I hope students also study the stick diagrams. Stick diagram is kind of layout, right? Now after the routing, almost placement is done. That is PD, almost done. Our design is in the form of layouts. What is schematic? The circuit level diagram can be called as schematic diagram, right? Layout versus schematic. Here we need to check one, whether the layout, whatever we have developed here at the end of the routing stage, is matching with standard cell or not. How? In terms of functionality. See here, in the PD, you don't know the functionality. From the starting, we are dealing with only circuit and placing them, interconnecting them. That is place and route. So that only we are discussing. But we are not talking about the functionality. But after completion of this stage, if this layout is not matching the functionality, then what happens? Waste. Everything is waste. So this is the stage where we need to verify whether the layout whatever we have developed by applying all these steps is matching with schematic or not. That is very important. That is what layout versus schematic can be done. Okay. After geometric layout, everything can be done. Next one is crosstalk. Did you hear the word crosstalk? Crosstalk and one more term comes here EM. Yeah. What is here? Electron migration. What is crosstalk? What is electron migration? These are the keywords what we should know. And ML also consider these keywords. See, here we are applying the ML algorithms just to catch the issue and then apply the solution. Apply this solution for that issue, right? Then ML algorithms should understand what is crosstalk. That already we are giving as an okay. Then don't worry. Yes. Next. Yes. What am I asking? Crosstalk. In layman terms, what is crosstalk? Unnecessary disturbance. Am I right? See here, there are two wires nearby. One wire is sending the signals at high speed. Other wire is not sending. That is holding the 0. Another one is sending the 1. In that case, what happens? This will produce the electromagnetic field, right? That will affect the nearby wire. Am I right? Whenever it is sending the data at high speed, that 0 which is passing in the nearby wire may become 1. Yes or no? So this will affect another one. Whatever wire is having the high speed data transfer, we can call it as aggressor. Aggressor is sending the data. Nearby wire which is affecting because of this can be called as victim. Aggressor and victim. Right? This leads to crosstalk. Right? That's why the rules again, the DRC design rule check is must and should. That will verify one check is distance between the two wires. Right? Distance between the two wires. Distance between the two wires should be maintained effectively. If that is not maintaining, then crosstalk will happen. Even after maintaining also crosstalk will happen. Then what we have to do? We have to make that as double rules. Right? That is NDM. Rules we can apply. Right? Double. See here always rules are minimum rules. There is no maximum rule. Did you see in the layout design rules maximum? All are minimum distance, minimum spacing, right? Minimum width, all minimum. We do follow minimum, even though there is disturbance. Like crosstalk is coming, then what we do? We can expand the distance between the two wires. Like that we can fix the issue. And what is electromigration? See, whenever data is transmitted at high speed, at times those are the metal wires. Metal wires, after 5 years, what happens? They may become weak. Yeah. Right? They may get damaged. That also tested. That is one of the corner we can use for that purpose. That means high voltage, high speed is applied and then tested EM. Understood? High voltage, high speed for a long time can be applied and tested EM. In that case, what happens? Electrons will migrate from positions. If electrons are migrating in position, then what happens? Disconnect will happen. Am I right? EM wave leads to disconnect the connection. Right? That EM effect also can be visualized here. That is, for that there is one corner to test the crosstalk and EM. That is what MMMC, which is the very first. Okay. Now these are the various checks we can perform. Finally, we can get DP and these are DEM. This is an Excel format. Now this is the format we will have all the layout information, which can be again tested for the performance. Right? We can call it as sign off checks. By this time, all the checks are completed. Checks are not completed, then that should be written. Right? That is what this criteria said. ML algorithms can take these criteria and can refine the checks. Right. So finally, if checks are meet, then it will go to range. Okay. Now understand timing closer. After routing, PNR completed. Placement and routing we can call PNR completed. So place design with interconnections is available and its layout also available, and that layout is tested against its schematic. LVS also passed. LVS not passed, then they have to retrace from the starting. Whatever it is. Here we have the complete layout, which is means not completely ready, almost ready for the manufacturing. Before manufacturing, what we do? We can check the physical verification. We can do physical verification and also timing closer. Timing closer means whether it is meeting all the timing requirements or not. Now here these are the timing requirements. What will happen? Right? Set up and hold timing, clocks, queue, insert delay, log these will come under the timing closer activities. Then you want me to explain all these things? Not required. Okay, setup time, hold time. Did you hear the setup time and hold time? What is setup time? Maximum time allowed between 2 points. Hold time is minimum time allowed. How much minimum data should be hold? How much time maximum is allowed for the data to transfer? This is the hold and setup time. Whether that is meeting or not in test. Right? That is one criteria. Next one is skew and insertion delay is met or not. Skew target will give you, cannot give zero target. We may give 1 PS or 10 PS, like that we give some target. Whether that is meeting or not. That is in terms of less than 1, not more than 1. Next is DRVs, that is maximum transition. Capacitance, all these DRVs are met or not. That is not meeting, then we need to apply some techniques. Next, IO delay, crosstalk, everything will be tested. Here, signal integrity. If you hear the word signal integrity, this is the against opposite to the crosstalk. Withstanding capability of the wire is signal integrity. Right? If the withstand is out of range, then crosstalk will happen. Right? Crosstalk is coming means signal integrity is there. Right? Both are almost same. Next, fixes. Now these are the fixes what we can use for fixing all the timing violations. Fixing all the timing violations. Okay. Yes. Now coming to the fixes. You understand these fixes? What are the fixes? What is size cell? What kind of mechanism happening here in the sizing cell? ML algorithm, how to perform this? It will verify whether the timing is met or not. That is not meeting. That can verify whether the delay issue, that is the delay issue. Then this technique is applied. So we need to understand what is sizing cell. That is another. That is fabric. Sizing scale is signal strength, right? Every cell will have driving capacity. Every cell will have driving capacity. Driving capacity means one cell can drive another 10 cells. Right? One cell can drive 4 cells only. Like that, driving capacity will be there. If driving capacity is 4, there are 8 are connected to that cell. Then what happens? DRV, that means transition will happen. Transition should be sharp. Because of the overload, see, here I am able to carry 10 kgs. If they put me, if they put 20 kgs on me, then what will happen to me? I cannot die, but my performance will affect. Am I right? Instead of moving 4 steps on per minute, I can move only 2 steps. Am I right? So if that should be the case, then what happens? They need to replace me with bigger person to carry 8. Otherwise, they have to remove the load. Removing the load from me is cloning. So here there is another concept, cloning. What they do? They distribute the load to 2 other cells. That means they will be moving one more same capacity person and they can put 4 from middle. Right? That is what cloning. The size cell is replacing with strength person. Right? That means strength will be enhanced for the driving cell. That means one cell will have 8, 10, 12. So they can change the cell. 12 capacity cell will be used instead of 4. 12 is required. That is what sizing the cell. And one more thing, signal integrated crosstalk will happen. When crosstalk will happen? When our data is over speed. So that if they put 5 years on me, then what happens? Instead of 4 steps, I can move 8 steps per minute, right? That is, I can reach very fast. That should not happen. I should reach within the specified time. So what they do? They can decrease the size. That means they bring the lower driving strength cells in that place. That is what sizing up, sizing down will happen based on the situation. That sense? That makes sense? Right? Next, coming to leakage swapping. There is more leakage power. There is more leakage power. What happens? Circuit becomes power hungry. Am I right? Circuit becomes power hungry. Leakage power. So in that case, what we can do? We can replace the lower threshold. See, the power leakage, supply leakage, voltage leakage will happen when threshold voltage is weak. Am I right? Right? Threshold voltage is weak. If I want to strengthen that, what I have to do? I have to replace that cell with more threshold voltage cell. That is what your friend said. VT swapping, threshold voltage. Right? VT means voltage threshold. There are many kind of cells nowadays. LVT, that means low voltage. HVT, high voltage, high threshold voltage. Right? Another one is standard SVT. Apart from this, now for lower nodes in the sense, low technologies, technology, there are ULVT, like that some more cells are come out. So that is probably ultra low. Low LVT means low threshold, ultra means further low threshold cells. That depends on the node. I cannot say exactly this would be. That depends on the node. See, all the cells can be applied for all the nodes, but depending upon the situation, we need to control that LVT and okay. Now these are the various techniques what we can use to fix the timing issues. So after this, time close also will happen. Then physical verification will go away. As per our flow, physical event has completed. After that, physical verification will happen. Okay. So these are the various steps what will happen in the physical design. And we have seen the criteria. What would be the major criteria that can be applied to take the decisions, right? So here ML algorithms are utilized for what purpose? To take the decision based on the issue. Am I right? That is what see. What is the difference between the experienced person and the less experienced person? Decision making only. Am I right? Yes sir. Same here also. Decision making is required for that, some criteria should be there. Right? Now already I have shown you the criteria which should be focused for ML algorithms. Okay. Now let us understand how ML can be applied for these concepts. See here. These are the rules for the macro placement. These are the rules I am giving to the ML. Macro placement is the one stage in the floor plan step. Am I right? Macro placements. What is macro? Some fixed logics, right? Which can be reused. Right? For macro placement, there are some rules. What are those rules? Place the macros to the boundary of the code. Why? We need to place them near the boundary. Any reason behind this? See here, there is big circuit. In the circuit, there are 4 macros. Not I can say 4 only. 10 macros are there. 1 lakh standard cells are there. Right? Macros are placed in the middle. What happens? Standard cells should sit at the corners. If they are sitting corner, that means from that corner to this corner, if I want to make a connection, what happens? Middle macro will become the stopper. Am I right? That's why if I make that at the corner, then what happens? These standard cells will sit here. So nearby there, connections will happen effectively without much effort. Am I right? So that is one rule. The rule is because of this one only. That is sitting in the middle, that can block all the connections. That should not sit in the middle, that should sit somewhere else. So these kind of guidelines we can use the ML algorithm. ML algorithm what that do? That can follow this and place the macros accordingly. We also do the same. First one can take 3 months. Express one can take 2 weeks. Place the macros. Here I am telling 10. There are 50 to 60 macros will be there. And those placing that 50 to 60 macros will be the challenging thing for the PD engineer. Okay. Now you want me to explain all the points? Just okay. These are the readable and this PPT is available for you. Yes. Rectilinear different shapes. As I said, the macros all are not square. They have the different shapes. That you have to see the different shapes also. All those information we can give. Right?
That is why we cannot tell that will be the good design.
Okay, you can say that.
So by trial and
Yeah. See, the shape is all are not rectilinear or rectangular. Some shapes will have different shapes. Whenever those different shapes are coming, you can fix them okay at the larger. Based on the dependency of other logic. Right? Based on dependence of other logics. That will be dealt with okay, in the real time scenario. That's not a problem. Macros can be any shape. Okay, they should not be always square. Well, because if that is a square, some portion will be wasted, right? So that's why they don't make. That's why square also they don't make. Circle also they don't make. Most of the macros size will be some rectilinear only. Any queries here? Same hierarchies. Yes, that is what we can see one guideline. Group the macros there are the same logic points. What is he asking? Same behavior. Macros can be placed together or not? Yes, that should be placed together. But because same behavior is like RAMs. All RAMs are storing the data. All storing data. Macros should be kept together. Why? Because those macros should be sitting beside the DLL. Okay, that's how these rules are formed. These rules are formed based on the experience only. Somebody have done the trials. From the trials, they have got some rules, and those rules are sharing with us as the new engineer. We follow these guidelines. Otherwise, we can break our head. They will tell follow, otherwise break our head. I am giving 2 days time or 2 weeks of time. Place the macros and give me. These are the guidelines I am giving. If you want to follow, follow. Otherwise, you place and give me. But that should meet the design requirements. If you have to, if you need to meet the design requirements, you need to follow guidelines. Otherwise, you have to form your own guidelines. Those again same, right? Nobody will tell you place the macro immediately. If you want to place. But connectivity will not happen effectively. So automatically pool will show legal issue. That will bring aside. Okay? Any question? Now read this. Now there are few more. That is, they give you another around 20 to 30 pages document in real, right? They will mention the distance between 2 macros should be 3 microns. That is rectilinear. Distance between 2 should be this much. That based on the shape again that will vary. Those all rules should be there. That is big document. But again, just projecting you guidelines. Okay. Now this is the ML model. what you do? It takes ML data from the tool, next user provided data, and then it creates its own data. Right? Now coming to performance limits. Yeah. Now see here, macro placement. You can understand how it is happening by taking the guidelines. There will be library, there will be user provided data, and then some database will be created on it, and that can be given to the ML algorithm. The ML algorithm will train themselves and provide us the effective or best methods. Right? Now next we come to performance. Now deep learning and logic design. Here you can see because okay, anyway, color is not coming. Now see here the macro placement. If I want to optimize, then what I need to do? I need to follow some guidelines, right? If I am using the ML algorithm, then ML algorithm can take these side steps, right? Now you can see here. Now this is the process done by the ML algorithm. This is the process done by the ML algorithm. What it is doing here? It is method of optimizing the performance. See here I kept performance device. To optimize the performance, what it has to do? It has to block shape need to be defined, right? As the very first step in the floor plan. That is rectilinear or rectangle something, right? Shape. Next, sizing. Based on the requirement, the shape can be sized. Finally, macro placement happens. Now, based on the macro, what ML do? That can follow the rules whatever we provide. After that will be placed. Then we can see here the required timing is achieved or not. That is what checks I said. Checks are met or not. Check means you can say timing is this much should be made. Right? That is meeting fine. Otherwise, again go back. Change the shape of the block. Right? Previously we can keep rectangle. Now we can go for square. Right? Again, these all trials can be done by the human. Human also can do all these trials, but human takes a lot of time. Am I right? And we need to analyze the data. Based on this data analysis, we need to take this step. But here, there will be its own database. ML algorithm will have its own database. In that own database, there will be previous equations. Based on the previous equations, we take the data. We also can take the data, but we need the experience. Right? We don't have the experience. But ML algorithm is having the experience of data with us. Okay, so that will happen. Now I have taken all this slides from the Google early. Okay. Fails, go back and then wait. If it is passing, then go to the next step. Now coming to the next. Now see here. Again here delay estimation. The delay estimation, we need to place the buffers, right? Delay is more, delay is less. Why delay is less? See, clock is coming. Before the clock, data should come. Am I right? Clock should not go early also. Clock data should maintain some delay between two flip-flops. I can say between two clocks, data should be maintain some delay. If the delay is not maintaining, then we can insert the buffer. Right? If that is not maintaining, we can insert the buffer. If that is low, buffer can be inserted. If that is high, delay is high, then what happens? Get downsize. That means not downsize. We can upsize the cell. That means driving strength is increased. I get what I mean to say. Now let us take one scenario. Delay is very less as required. In that case, what do? We have to add the delay. For adding the delay, what we can do? We can put the buffers in the middle. Am I right? So delay can be achieved. That is one case. Second case, there is more delay. Right? That is data is reaching okay after the clock. After the clock in the sense not as required. Very after. In that case, what we need to do? We need to slow down. That means we need to decrease the delay. In that case, what I can do? I can increase the drive strength of the cell. Drive strength. That means which can carry 2 load is replaced with 8 carrying load. 8 load cell. In that case, what happens? That can be fast. That can throw the data very fast. In that case, what happens? Delay is reduced and meet the requirement. For all those things, again, ML algorithm what you do? You can estimate, right? Delay and then use the buffers and then it can insert the buffer. Before inserting the buffer, you can verify the layer or which layer it can be inserted. All those things. Internally, we need to do a lot of adjustments. Not just inserting the buffer is not enough. We need to see what layer is used for the connection, and if that layer is M7 and buffers suitable for M7, there are some set of buffers. Those buffers only we have to use, and some buffers will have certain delay. And again, we need to see the delay of each buffer, and whichever delay buffer is suitable here, that only we can use here. These all things will happen internally. So ML algorithm what it do? We humans what we can do? We can open the library, we can search for this one, and we can see cells are available or not. All this process we have to do manually. ML what they do, that internally do, and if you bring up the, okay, this is the buffer perfectly suitable for this particular layer, and then retrigger the run. Understand? So that is the iteration happens. See here, for this process, for this is what. Okay, and after this, if it meets the requirement, then okay. Otherwise, go back and then redo the. Actually, this is already happening, but manually we are doing it now. So this can be transformed into ML. Now next. See here size, gate sizing. For example, right? Now see here. For example, delay is more, then what we can do? We can use the high drive strength. Otherwise, we can do the logic restructuring. Logic, what is the meaning of logic restructuring? Boolean equation. You might have seen the concept of Boolean equation. Boolean equations are derived. Directly we can derive, otherwise we can apply some rules. While deriving Boolean equation, some rules are there. What are those rules? There are some rules, right? Those rules can be applied and a restructuring will happen. Or pin swapping also will happen. Pin swapping means this side one pin is there. We may put this pin to this side, right? Those kind of adjustments we can do while solving the issue. The same adjustments ML also can do, right? While doing this. Right? This is happening at placement stage. Now see here routing. Now see here between the routing and sign off. Right? Now we need to do some optimization. Right? Here again, as I said, the layers plays the role. In the routing, we cannot do anything with the cells. Cells placement is done at the placement stage itself. Only thing what we can do is wires. If lower metal layer is used, lower metal layer means having more delay. That is providing more delay. Then what we can do? We can replace that lower metal layer with higher metal layer so that delay will be reduced. Am I right? All these sign offs we can do here. Right? Here also, again, this is done by the engineer manually. Now this can be again taken over by the ML algorithms here, estimating. Right? The layer assignment. Right? Then driving time driven will be given in the static timing analysis. It checks whether the timing is meet, then it goes to the next. Otherwise, reassign another layer. Right? Metal 3 units for the single connection. Then they get into metal 4. Right? That is not working out. Metal 5, metal 6. Like that, these equations. ML algorithms will provide us the best results while iteration process. Okay. Next. Now finally, these are again takes the rules and again level versus schematic, antenna effect, and the electrical rule checking. These all are the sign off checkings. At this stage also we can apply ML algorithm. Check this and find the issue. For that issue, we can go for adjustments. Finally, those adjustments are working out, then okay. Otherwise, go back and re-repeat. The re-iteration will happen. Now here also, ML algorithms can be used. Simply here we can take that ML is experienced person. Right? Here also in industry also what happens? As I said, whenever you teach the subject 4th time, what happens? You will be more and experienced and handy. Concepts are handy. But first time, you need always helping. Right? But here ML algorithms uses will avoid the first concept. That is always act as expertise resource. Resource means engineering. Expertise engineer. So they can have the previous information in their mind, and we are giving the new information, new rules as per my company guidelines, and also that can iterate. First that can use in this case metal layer 3 that can extract some data, then 4 extract some data, 5 out of these 3 which one is better, that can be fixed as the final. That also we humans do, but that takes time. But this will take that. Okay. Yes, that almost concepts are done. Now let us see the application. Another 5 to 10 minutes back. Okay. Now it's already 2 hours over. Now you can see here already we have discussed most of them. ML can be applied at the location of the standard cells. Right? How it can find the location? Based on the density. Based on the density. Okay. Next, routing condition. There are more routing layers. Then what that do? That can distribute the routing layers. For that purpose also we can use. Right? That is, we can mitigate the routing by identifying the areas where wires are likely to overlap. Right? Routing optimization, do the optimization of routing. Routing layer means that can change the layer, that can pick the perfect metal layer which can be used for long distance routing, short distance routing. For short distance routing, we can use less metal layers. For long distance, more width metal layers. That means higher metal layers we can use. All those things we can take in here. Then next, skew minimization. We can set this skew, particular skew. To meet that skew, again iterations required. Right? Iterations required. Skew setting is again the delay game. Right? Delay is more, we have to reduce the delay. Delay is less, we have to increase the delay to meet the required skew. Right? All those things will happen here. The timing process already we have discussed all these things. Okay? ECO means engineering change order. ECO, engineering change order. See, this is one terminology I want to tell you this. Everything is done. At the last stage, we find some fault. We cannot go back and do complete process again. In that case, what we have to do? We have to alternate the design. That means one cell should be there. That cell can act as AND gate, OR gate, NOT gate, whatever gate required to fix that issue. Understood? Like this. You can call those cells as spare cells. That is also one of the physical only cell. Physical only cell. That is spare cell. That means some cells we can place in spare. We can use those spare cells to fix the issues. Right? That will happen at the EC version. EC version means we are not done and ready to go for the tape out. Tape out means manufacturing unit. Ready to go for tape out. At that time, if you find some issue, that issue is logical issue. Then what we have to do? We cannot change the complete structure. Again, go back again. That takes a lot of time. In that case, what do? We use those spare cells and we can fix at the last moment. The spare cells is not there, we are hopeless. Am I right? That's why one of the physical cell is spare cell that will be placed at the fourth plan itself. Randomly, spare cells are placed somewhere. They don't do anything. They have the connections. They are used fine. They are not used. They can tie it to the 0 and 1 using the tie cell. There is tie cell also placed. The tie cells are used to tie them to 0 or 1. They are used. Then that can be used at the sources. Okay. Now these are the various places where we can apply ML algorithms, and we have seen one thing, and this macro placement. Now using the ML, we can achieve all these things. And the very second slide itself, I told you. Now these are the challenges in the industry. Am I right? So by applying the ML algorithms, we can achieve this. Right? You can see here. Right? APA. Do you feel that can be achieved by using the ML algorithms iteration process? Similarly, faster design cycle will happen. Yes. Next, more accurate designs also can be done by using ML. Then reduce the design cost. Yes. Instead of 4 engineers, only 1 engineer can do. What that engineer do? That engineer will feed the information to the ML algorithm. That will give the results. Instead of 4 engineers, 1 engineer is enough to feed. Okay. Finally, design flexibility. Right. Now here you can see the chart here. This is actual human intelligence. Use the MLs. Here, cost and runtime both will be reduced. Accuracy will be increased. Right? Or at least we can maintain the required accuracy. Okay. But I cannot say accuracy is 100%. So because humans can do the mistakes in the process, but targets will be fixed by the humans based on the real time requirements only. Am I right? And we know the experienced engineer can do better than the ML. But ML algorithms can reduce manufacturing cost as well as energy cost. And for ensure the accuracy, real engineers is required. Okay. Now with this almost done. Okay. These are the challenges. Now I will, about the challenges. Getting the data and feeding the ML algorithm is very difficult because we have the less data documented at present. So we need more data that will be given to the ML based algorithm. It requires large amount of data to train effectively. Computational requirements. ML algorithms require high speed chips that we are working on the high speed chips only nowadays. Right? Integration of those techniques, whatever we have discussed until now. Okay, we have discussed ML can be used for this purpose, this purpose, this purpose. But all those things using EDA tool is not easy task. That takes a lot of efforts. Okay. Finally, maintenance and updation is very important. Maintenance, okay, will be done. Updation is very important. Right? Updation can happen periodically. Right? These are the various challenges to use ML algorithms. Right? Before this, we have seen what are the advantages of using the ML algorithms. Before that, we have understood what is PD and how to apply ML algorithms. This is what I wanted to discuss with you. If you have any queries, please come up. Let us have various clarification. Then I will enjoy Did you understood some concepts? Is it useful for you? Anyway, I will ask